And I'm back. All right, so now we're going to talk about coterminal angles. Coterminal angles means they have the same initial side and the same terminal side, but they're different angles. So if I have an angle that is right here, that's my angle. Okay, this is my initial, this is my terminal side. So this is my angle, I'll call it theta. We could find another angle that has this as the starting point and that as the ending point. That's different than theta. What we could do is we could go, well, we're going all the way around and then we're going back to where we were. Okay, so let's say our initial angle, let's say it was 40 degrees. How big is this angle right here? Well, we've added one whole revolution, and one revolution is 360 degrees. So if I added 360 to that, I would get 400 degrees. So 400 would be coterminal with 40 degrees. All you have to do is add 360 degrees because we're adding one revolution. We could add another revolution if I wanted to and add another 360, and 760 degrees would be coterminal also. So there's an infinite amount of coterminal angles. We're going all the way around and around and around. If we wanted to, we could go backwards. We could start here. Maybe I'll use a pencil. Start here and go backwards. And that still has the starting point and the ending point, but it's a different angle. So initial and terminal side. Well, how big is this angle? Well, the whole thing is 360. That's 40. So that means this is 320 degrees. So this one would be 320 degrees would also be coterminal. How could I have gotten that? Well, if I started with 40 and I subtracted 360, in other words, go backwards 360 degrees from there, I would get negative 320 degrees. So it's negative 320. Okay, so you don't have to draw it every time. You can just literally add 360 or subtract 360, and those are always going to be coterminal. So if they are in radians, instead of adding 360, we're adding 2 pi, because 2 pi is, let's see, 360 degrees. In radians, we'd multiply by pi over 180. So 360 over 180 is 2, so we get 2 pi. So one revolution in radians is 2 pi. In degrees, it's 360. In radians, it's 2 pi. So if I wanted to go all the way around the circle, that's 360 degrees. It's also 2 pi units. Okay, so if I was going halfway around a circle, if the whole thing is 2 pi, this would be pi radians. That angle would be pi, and that's 2 pi. So if I was going to look at my initial angle of, we'll go right over here. We'll call that 2 pi over 3. If I wanted to find a coterminal angle to that, 2 pi over 3 is 120 degrees. Sorry. So it's 120 degrees. Coterminal to that is we could add one revolution to it, and we'd have our answer. So we could go 120, add 360, and then change it back to radians. Okay. So I get 480 degrees, but our initial angle is 2 pi over 3. So coterminal 2 pi over 3 is 480. That's not how you should write your answer because it's given in radians, so we have to convert it to radians now. So 480 times pi over 180. Let's see. It would be 8 pi over 3. Okay. I think an easier way of doing it would be to just go back and look. If I'm given 2 pi over 3, one revolution is 360, or 2 pi. So I could literally just add 2 pi to it and we get our answers. 2 pi over 3 plus 2 pi, well, that's the same as 2 pi over 3 plus 6 pi over 3. Now they're common denominators, so I can add them and I get 8 pi over 3. So 8 pi over 3, just by adding 2 pi to it, gives us a coterminal angle. We could also go backwards, start here and go backwards, and that'll give us a -1. So it'd be 2 pi over 3 backwards revolution, -2 pi, or subtract 2 pi. So it'd be 2 pi over 3 minus 6 pi over 3 gives you -4 pi over 3. There's another coterminal angle that ends up being a negative angle. All right, we'll call that good.